Okay.
All right, everybody, welcome. So we just had news this morning that Sanctuary AI, competitor to Tesla, dropped a new version of their Tesla, their humanoid bot. I've got Scott Walter joining us. Scott is a two-time robotics founder. And let's get started with the news. So this morning they had a press release. Sanctuary AI unveils the next generation of AI robotics. This is their new Gen 7. So they've continued to improve this, and it looks like that about every 12 months or so, they will have a new version. This one has quite a number of improvements. So they've got improved human-like range of motion. They've got improvements in uptime, visual perception, sensing, design iteration, and the speed is a lot faster. Let's go ahead and watch what they dropped here. So I'm going to take out the audio. What do you think, Scott? What are you watching here?
Okay, so it looks similar to what we had before, but we can see there's definitely a lot of refinements in there, and we'll have to go through almost a frame-by-frame analysis to really get a good idea. The extended range of motion is something that I guess we sort of expected was going to happen, because Suzanne kind of hinted to something like that when we interviewed her about 2 months ago, that they had some range of motion that maybe didn't quite capture what was the actual human range and wanted to extend that. So that's probably part of what's going on. The hands do look a little bit more dexterous than before, the improvements in there. So there's probably a lot of improvements that are, underneath what we're seeing as opposed to what we're seeing from the outside, because there's a lot of similarities without having like a side-by-side of the Gen 6. And again, coming up with another generation right now is not a surprise, because like you say, they've been doing it about every 12 months. And I think it's been more than 12 months since the sixth generation had come out. And I'm sure they learned a lot about what they wanted to do to make the modifications. So at first, I think if we look down at the hands, if we see something here, there was usually some cabling. And I'm wondering if that cabling there is now removed. That's the first thing I wanted to know.
Yeah, let's go to this frame by frame. So improve commissioning and build speed. What would that mean?
Okay, yes. So the first thing is that, obviously they are focused, and I think somewhere else they say something about, reduced material costs. So they're getting focused on how do you build these things at scale now. And if you just hold that for a second, I think, is that the waste mechanism that we're seeing down there?
That's the waste. Mm-hmm.
Okay, because I'm trying to see if they're doing something similar, but probably not as we go up. So we see that you have the vertical axis rotation there, and then you've got something there which is giving you the horizontal rotation, which looks like the lean forward axis, and then another. So I think that's the same design that they've had before. Okay.
It looks fantastic. It looks much better than it used to. That's
Very
the hands. They spend a lot of time on the hands. And just to catch up all the audience, Sanctuary, one of the things that they are very different than all the humanoid bots, they spend a lot of time on two things, which is the hand dexterity in the fingers and the intelligence in the brain. They think that these are much more important than the actual walking. And you'll see that they actually don't show the legs or the feet yet, but they show how they are. And I'll show a video of this later. They have the fastest pick and place demo at this point, and it's their fingers. Look at very closely their fingers. Right. They're much more advanced than anyone else's. What they say.
And what you may not notice right there is that the three hands that are curled are a little bit off the side, is because they can also splay the fingers out like this as well as doing that. So they have more freedom of movement in their hands than the other bots. And it does look like a slight, refinement to what they've had before. Better looking hands.
Tactile sensors.
Yep. Mm-hmm. Yep. And I think they always had tactile sensors. So they probably just made improvements on that, because Suzanne had already talked about making sure that they have a similar sensorium as humans, and that tactile they feel is very important. And responsiveness is going to be very important as well. Mm-hmm.
Yeah, the side of the head.
It looks like they got quite a bit in there. I wasn't sure how much they had in there before, but I assume they had like a vision system in there, but they may be packing a little bit more up there, because we can see the vents that are there. So that means you probably have some electronics. That
we saw the same thing with
actors. Mm-hmm. Mm-hmm.
We saw the same thing with Boston Dynamics, where almost all the other humanoid bots, they actually have a empty head.
Yes.
Only so far, Boston Dynamics and these guys, we see that they actually have vents. They're using that space for something.
Yes. Yes. So ideally, you would like to have the head as light as possible, so your center of mass stays as low as possible. But the problem with, if you put everything in your torso, then you're taking away space for something else. And so they're probably taking things that maybe volumetrically take up a lot of space, but maybe are not very light, like PCB cards and other things like that, putting them up there, and then giving your chest cavity more room for batteries. And that would improve your runtime as well by doing something like that.
Let's take a look at the evolution of the head. So I guess that
Mhm.
was the early head. Then they came up to that middle one. And
They have a
now
lot of
they
cameras
decided
up there. Yeah.
That's 3 cameras. Why do you need that? 2 eyes up the top and one big giant one.
Yeah, I'm wondering if it's just to give a wider field of view. I've always wondered why my iPhone has like 3 lenses in the back there, and part of it
Oh,
might
yeah.
just be to get better depth of field and everything else. I don't think that's LiDAR that they have up there, but it might just be that they want to have different fields of view.
Okay, so that head movement going up and down, you've been pointing that out, right? Everybody can do that same head movement, but that range of motion is a lot more than we've ever seen.
Right. That seemed to be really being able to go down quite a bit. So yeah, that's really looking down. Most of them may not go down that far. And of course, they have other range of motions that the other bots, most of them do not have. And that is, obviously the ability to turn the head side to side, but also to be able to do that side to side nod, which I don't think they show in here, but it is there.
Let's continue on the press release. So they said include improved human-like range of motion. Do you think at this point that the range of motion you've seen in that demo is more than what you've seen others?
No. I think it's what they're trying to do is they're trying to get it closer to the human range, because I think Suzanne mentioned that they may not have had quite enough like in the wrist movement. So, and we talked about like the hand side to side. I think they had some, and she said, there are some cases that, the teleoperator was able to go a little bit further than the bot. So they want to make sure that if you're using it for telerobotic operation, for training, that you're able to absolutely do a much better mapping to the human. So that's, I believe, what they're trying to do with the human-like range of motion.
Understood. Improvements in uptime, visual perception, tactile sensing, increase the capability of the system to perform complex tasks over longer periods. So is uptime the battery? Yeah.
That could be part of it, improvements in the uptime of the battery, but maybe just overall reliability, making sure the system is able to run for longer periods of time. And because, it's like to perform complexes over longer periods, that's very important to being able to make sure that you could do useful work, more than just a lab demo, but being able to actually do something that would be production for a long time. So we don't know that much about what the current runtime is like and what exactly those improvements are going to be.
What we're watching here is video of the previous generation of their bot. You can see that this is, let's start from the beginning here. This is Jordi, the CEO. That's looks like the previous version, maybe even 2 generations behind.
Yes.
That's Suzanne Gildert, the CTO. Scott and I have interviewed her. If you want to take a look at that, it was a very amazing interview. She is brilliant, and she talks about things that you don't normally hear from the other executives of humanoid bot companies, because they really are taking a very different approach. They're looking at the hands. They're looking at the intelligence. Both of these came from quantum computing company in the past. So their background is more on the computing side, which is very interesting. And of course, Suzanne has been a roboticist for decades, ever since she was a kid. Jordi Rose is the CEO, and Scott and I will be interviewing him early next week. So watch out for that. And you can see that they show the chessboard, because that was one of the things that they were further ahead than everyone else, is the fingers. This is the pick and place. And this is something that many of the companies are showing you, the pick and place, but you'll see that, again, Sanctuary is, at this point, their demo of the pick and place is faster than any other humanoid bot at this point. And so that was at 1 speed. And then they actually then, accelerate. Okay, wait. And then now you can see both hands moving at the same time. And then they're really going much faster than anyone else has been able to show up. So this is something they dropped, I don't know, maybe 2 months ago.
Yes. Mm-hmm.
So that's their focus. Is you see the upper body, the hands. They think that um, if you can do real hand dexterity, that's what's going to make it more human-like and able to use more tools. Yeah.
Yes, and part of it is trying to train the brain. So they've talked about sort of the three foundations that you have. You need to have mobility, you need to have dexterity, and you also need to have the brain. So they've been focusing on two of them, the brain and the hands. And part of it comes down that, one of the theories is that the human brain and the human hand kind of co-evolve together. And they're seeing that that's a very important aspect to be able to train the AGI that they would like to get with embodiment. And that's why they want to make sure you also have the similar sensorium for the training sets, and why they put a lot of focus on also having tactile sensors, not just force feedback, but also tactile and vision. They imagine they must also have auditory in there as well. You want to capture all that.
So the other thing about Phoenix, Sanctuary's bought, is they just partnered. Was it 2 weeks ago now? It's just time is flying so fast. They made a big announcement with Magna. So Magna is a large automotive supplier, like massive. They're in multiple countries. They are actually the company that builds, in some cases, the full car, and in some cases, parts of the cars for a lot of the large auto OEM. They're the kind of the manufacturer behind the brand. And they partnered with Phoenix and Sanctuary. They're actually investing in them. Several years ago, they're an investor. They've upped their investment. And then now they're saying that they're going to introduce the bot into their actual factories and going to be the first customer. But also, what's so amazing is that this is the same partner that's going to actually manufacture these bots. And one of the things that you'll see here with the introduction of the Gen 7 is they talk about that the design iteration significantly decreases build time, and then the speed at which tasks can be now done is 50% more than the previous one. And so they spend a lot of time talking about improving the hardware and making it better.
Yes. And those are some of the things I noticed in there, that they had words like cost reduction and making it easier to manufacture. And part of that might be something that they've learned internally, but also with a partner like Magna, they would be able to come in and really help them with the overall design and tell them this is what you need to do for manufacturability. And so I wasn't expecting, I guess I was expecting that they would be getting some assistance. I just wasn't expecting it maybe to come that quickly. So it means it's probably something they've been doing already in the background before that announcement.
Yeah, they've been around for a long time, right? They're one of the older humanoid bots, but things are moving fast. You can see here they talk about, by the way, their brain, the AI control system, they call that Carbon, and their general purpose robot, they call that Phoenix. And Suzanne has actually told us that they are more focused on the brain, that such that they're willing to partner with other bot manufacturers. So they are actually bot agnostic, but of course they're working on their own. And then look at this. The announcement comes less than 12 months after their 6th generation. And that 6th generation, they were actually on Time Magazine, Time's Best Inventions of 2023. Then 16 months after, that one was 16 months after its 5th generation. So it looks like that they're accelerating the generations that they're making.
Right. And that's one way to think about it is if you're trying to solve for the brain, you need a robot to work with, and if there aren't any available out there, you got to build your own, very much if you think about, Waymo, like, well, we want to solve full self-driving, but we need a car. So you've got to put it on there. And the idea is that you may be agnostic, but you've got to have some kind of chassis to work with. And they probably felt that in order to solve the problem, they needed certain kinds of functionalities that they could not find with any other partners at this time. So you go ahead and start building your own bot. And that makes perfect sense. And if they decide at some point that they don't really need these designs anymore, they're not going to actually sell them, then perhaps that's the way they're going to go. But I have the feeling with this is that, they are thinking of developing, more of the hardware on their own, especially if they feel the capabilities are pretty good. And if they think that there's also usability. So it doesn't mean long term that they wouldn't decide, okay, we'll just partner with someone else. But in the short term, it probably does make sense to continue to develop their own hardware to produce the kind of functionality they want. And if you also look what was just kind of quickly shown there in that scene, there is a lot of applications where you only need the upper body. So there are many places in the world where cells are set up where the operator is not really expected to use their legs or their feet at all. They're just going to be in one place, and at most they might spin side to side to be able to grasp something. So, you've got a torso that's able to do it. But in those particular instances, the hand dexterity is really important compared to the others. Usually the ones where you have to do walking, the hand dexterity is not quite as critical. If you're just picking up a box and bringing it over and dropping something, doing that back and forth, it's almost the mobility is more important than the hands. But if you're more stationary, in those cases, you really need the dexterity, which is probably why they are not really focusing on the mobility aspect right now, but really focusing on dexterity and with that, the brain.
I wanted to point out that what we're looking at here on the screen is the old version, the previous version. And let's take a look at the differences between the new version. So you were saying this, right? Right here, what is this giant pneumatic? What is that? Is that a
tube? I think it's either pneumatic or hydraulically actuated hands. And I think they've refined that a little bit. They're still using that. But I think it's not as obvious in the new version.
I don't see that anymore. So it's
hard to say. If you pause it right there, you do see some cable. Yeah. So you do still see a cable coming in there to be able to do the actuation.
Well, it's not that giant one anymore. That's a huge improvement because of course, if this is going to be scaled, you're going to deliver it as a cobot working besides other humans. You can't have giant wires like that sticking out. It's going to get caught. Oh, I see. Oh, I didn't see that.
Yeah. It's just.
Oh, so that's right here.
It's still there. It's still there. But I think what they've done is they've probably been able to scale it down a little bit, so it's not as bulky as it was before.
But Scott, why do you even need this? Like other bots don't have this.
I think it's because they're doing a different actuation strategy. So I think she said they're doing it hydraulically for the hands. So the rest of the body is electromechanical, but for the fingers, they're doing it either hydraulically or pneumatically, most likely hydraulically. And the only other way of sort of doing that is with tendon drives, or you need to take actuators that you can fit in there. And the thing is, your hand is so small. It's like, well, where do we fit the power? Because nature figured that out, that actually the power source for her fingers is up here in her forearm. And it's through tendon drives that we are able to move our fingers around. And that's something that's mechanically a challenge right now to do it. And so they've decided, let's go ahead and use a different technique that, could be refined, could be changed in the future, but that's the approach they've decided right now to give them the kind of hand dexterity that they are looking for.
Can we compare the hands of the Tesla bot with the hands of Sanctuary Phoenix? So
yes,
Sanctuary Phoenix, this is the hands, and you're saying they're using pneumatics so that they maybe the fingers are going to be much more powerful. Maybe they're going to be more like every finger might be able to be like this part here, right? Every finger is controlled. Improved tactile sensors so that you can
also notice how the
difference.
finger is kind of split apart there. You notice how the fingers do that. So they have an additional degree of freedom, and probably by actuating it that way, it makes it easier for them to be able to get that kind of movement. Whereas it's not just Tesla bot, but everyone else has an 11 degree of freedom hand, which,
Tesla seems to be able to do it too, though. So
they can't get the fingers to go out like this. I mean, they
look at that.
They get that. So that's good enough kind of, let's say, dexterity for a lot of tasks. And sort of what we said is that for a majority of tasks, probably just being able to do the clenching movement is enough. How often you need to move your fingers out like this, that's kind of questionable whether you need that, except with extreme dexterity, or as we said, if you want to play the piano, you need to be able to do that. If your fingers can only do this, you're not going to be able to play the piano. You need to be able to move out. And it doesn't mean that these bots need to play piano, but you never know. There could be a task where for some reason your fingers have to come out, but that's a rare task compared to normally just being able to do this. So I would say this example
if it can fold a shirt like this one is showing you, it's teleoperated, but that doesn't matter. What matters is they're testing to see if the fingers and the hands is sensitive. If it can fold the shirt, it can do almost anything. Look at that. It can do 2 fingers. It can move things. So to what extent does so what exactly can Sanctuary's bot can do that Tesla bot won't be able to do, for example, because they focus so much on the hands?
Again, probably things of very, very fine dexterity. So even then, the t-shirt folding, we've seen you could do it with a gripper with 2 fingers, or not even fingers. It's just very simple paddles that are on there. So so there are definitely applications where you don't need all your fingers, but there are others where you may actually need Perhaps like, threading a needle kind of applications that people have talked about is like you do want to have fine motor skills, and you may need to have something that's a little bit smaller. But yeah, I mean, we're just so used to our environment and how we're able to manipulate everything more easily with our hands. The fact that we have these fingers means we can take sort of different forms or different shapes to be able to grasp certain objects in a more natural way, as far as we're concerned, as opposed to something that may just have a paddle that comes together like that.
I mean, this is what they dropped just a month ago that so far we have not seen others copy, but it's like double hands, both hands moving at the same time. That's unique, right? I mean, that's
Yes.
what bots can do that some humans can't do, but many humans can. What's the difference between this clip and then this next clip here? 1 point accelerated. So then they said, let's do it faster even. This is February.
Accelerated imitation. Okay. So this is imitation learning, so that it's been trained telerobotically, and now it's able to
do it
run itself based on that. So it's autonomous mode.
Yeah. Okay.
And a lot of that comes down to not just the fact that you have mechanically able to achieve that speed, but also your control system, the AI, is able to come up with those movements very quickly, and it's able to respond really quickly. So those are two things that are important: is be able to think quickly and also be able to move quickly.
So, okay, let's go through the list. Tactile sensors, improve force and resistance feedback, visual perception, data visualization. What's that?
The data visualization, I didn't quite see that. I was kind of focusing on the fact that they have the force feedback, and looking at the different kinds of cups that you're picking up. Depending upon what you're picking up, you need to make sure that you apply the right pressure. So in one case, you have something which is, much harder and a little bit heavier there in the sense of a coffee cup. So it's more ceramic. You have glass, and then finally you have a plastic cup. And we know that if you apply the same force that you apply to picking up a glass to a plastic cup, that plastic cup is going to deform right away. So, and I guess part of that would probably be also from improved visual perception, because there's two ways that we can pick something up. Is we can close our eyes and go around and try to grab something. And as we notice it's deforming and collapsing, it's like, oops, that's, I have to kind of back off. The other is to know ahead of time that that's a plastic cup you're about to pick up. Be very gentle and careful with it. So the visual perception is also going to be part of that feedback loop. And we've talked about that again and again, that it's nice to have the perception in your hands and the feedback, again, if you know where an object is in space, just because you've been told where it's supposed to be and you go there, but you'd be surprised how much we're able to do with our eyes. Our eyes helps us with the planning and the expectation of what something is going to look like. And so that comes from your training sets of training on different kinds of objects and realizing what the anticipated forces or pressures need to be to pick up a certain object. So we know that if we see a suitcase or something like that, the expectation, that's going to be pretty heavy. We go over there and we prepare ourselves. We might even, kind of go over and test how heavy it is and then get ready to go ahead and do it. But we know there are other objects that might be very, very light, like a pillow or something like that, where it's going to be very easy to pick up. And that also helps in the planning of the AI, is like not to wait to the last second to find out what is the object you're picking up, but to know a little bit about it ahead of time, just based on past experience.
This is the backpack, right? So this is where the battery is in the back. So it's a lot smaller.
Yeah. So improved miniaturization. So that means it's going to give them a lot more space to be able to put other objects in there that you can't miniaturize very easily. Batteries, we're trying to get more energy in the batteries. It's like a little bit of improvement here and there, but in the end, they take up a lot of space, and it's very hard to miniaturize a battery. But if you can make more room for the batteries, then you'll be able to put more in there. And that would obviously give you more uptime.
Okay. What do you think about what you saw then, Scott? I mean, this is took them 12 months to be able to upgrade from Gen 6 to Gen 7. So first of all, they're Gen 7.
Right.
Tesla bot, they say that there's Gen 2, although we know that they kind of started off with what they called it, Bumblebee. And this is Gen 2 of the next generation of Tesla bot. This one here that they dropped in December. So Tesla, I mean, obviously they look amazing. This is like so clean, so small, so thin. they also have the waste is already much more cleaner. But for these guys to come out with Gen 7, that's fantastic, right? This is now, again, they're focused on something different. They're focused on the fingers and the brain.
And they do want to build a certain number. And I think Suzanne also sort of mentioned that, it would be nice to have like a certain fleet that is operating in the real world, because the differences between the simulated world and the real world physics, but they weren't really ready to scale up yet until they found the right design. So that's one of the things that they've been iterating on is that they kind of want to design lock it and make sure you have the right design. And when you do, then you start thinking like, oh, okay, now we're going to produce a larger number of these things so we can increase the size of our training fleet in the real world. And that's probably part of the reason why they want to make sure that the build time is a little bit faster and that their cost structure is going down. Doesn't mean that they're necessarily looking to build a $10,000 bot that they are going to be able to sell to consumers tomorrow. But what it might mean is that for their internal use, they are trying to figure out, okay, how do we do this first round of scaling that we need to do to be able to get enough bots in our fleet that we can start doing more and more training.
So these guys partnered with Magna, which we explained earlier, so automotive supply. They are planning to go into the pilots, into the actual factory. And then do you think that based on what you're seeing here, Scott, that these guys are ready? They also partner with Accenture, by the way, which is obviously a massive consulting firm that can introduce them to other companies, factory or other kind of retail or other companies in the first place. So are they setting themselves at this point for mass scaling and for mass, distribution? And do you think that what you're seeing here, is there going to be a Gen 8, a Gen 9, a Gen 10 before they're ready?
There always will be. And the question is who the target market is in this. And I would think from what we've seen with Magna, they're really looking at going into the factories. So the design that they have here is going to be adequate for working in the factory. It may not be what you'd want to see moving in the house, but it certainly is going to be good for being able to scale up in that particular environment. So, and again, we haven't seen enough about how the mobility is done. And even then, it could be that a lot of the power is actually coming directly from, from the wall as opposed to coming from a battery pack. So they could be plugged in.
Anything else you see that's unique about this versus the previous version?
Not enough. I think there's refinements I've seen there, but as far as like the degrees of freedom, the kind of mechanics I have there, it's similar, but again, they're letting us know that they've improved the dexterity of the hands, the tactile sensor is a little bit better. So I think what's happening is there's more refinement, which is sort of what you'd expect from Gen 7. From Gen 1 to Gen 2, you expect more radical changes. And then as each generation comes out, you're refining and refining. It's not like you're going to see a radically different kind of kinematics unless they discovered something along the way. But hopefully that's what they figured out between like generations 3 and 4. And I think Suzanne had mentioned that they may have, in the earlier designs, even had like a 5-degree freedom neck just because they were trying to make it way more human-like. Yeah. And then they realized that, we don't have to. So it's not like between 6 and 7, they're suddenly going to say, we got the neck design completely wrong. Let's go back to something else. So I believe most of these things are just finding a way to get to scale a little bit better, reducing the cost structure, and again, the normal kind of refinements that you would expect as you get into later generations.
Okay. Wonderful. Thank you so much, Scott. So basically, Sanctuary dropped a new version, Gen 7 of their Phoenix robot. They partnered with Magna that's going to help build the bots for them, that's going to introduce it to their own automotive supply factories and have invested in them. And they partnered with Accenture as well, that's going to help introduce them to more clients. And it looks like that in Gen 7, it's a much cleaner, beautiful bot. I do like it. And then the key thing that you're looking for with this kind of demo here is they have said that their focus is the hands. So if you look at the hands, this is the area that they want to be further ahead than everyone else. And they've got improved tactile resistance. So far, we've only heard Tesla to have the tactile resistance, Tesla bot, but looks like these guys have it as well.
I think they always had it. I think they've had it all along.
No, they have. I know, but I'm just saying that other than Tesla bot, Sanctuary's Phoenix also has this. And look at the fingers. The other thing too is like, the joints of the fingers, it's more human-like. You can see that it's actually, right?
Yes. So it has the 3 knuckles rather than 2. Yeah. Yes.
Versus Tesla, they decided to stick it with 2. looks like.
Yes.
Two.
Yes. Yep.
Yeah. You know, it's like, because it's for mass scaling. Like, and one of the things that Scott's pointed out, if you look at Tesla, every single finger is the same finger. So,
Right.
you know,
and if you look at your own finger, out at the end, the distal part of it, that tends to not move as much as the other two. So you can make the argument you almost don't need it. And they have it kind of pre-curled a little bit in the Tesla bot. But, you know, there'll be others who say, well, you know, when you really get down there, it does seem like your finger is moving a little bit. So it's one of those engineering trade-offs you try to do to reduce cost and make things a bit more reliable. And remember, Tesla did not have the touch sensors the first time. So if you actually look at their 3 generations, each of the bots is very different. And when they went from the first one, they learned a few things from Bumblebee, what they needed to get in the Gen 1, and they added a few joints. And then going to the next generation, Gen 2, it was very similar kinematically, except they decided to add the head movement in there. So all they did is they refined everything in there and made the bot look very nice. When we go when a Gen 3 bot comes out from Tesla, it probably won't look that radically different than Gen 2, not like going from Gen 1 to Gen 2. Now, Figure also started out with putting the tactile sensors in there as well. And they said that they're not sure that they need them. So they're also running the testing where they need to have them or not. So Tesla didn't have them put them in. Figure put them in and may decide based on their own testing to take them out because it seems like they can get away without it. But Sanctuary has always all along said the sensors are in there. They're staying in there. We believe you need them. And the question is whether you need more of them.
Yeah. Okay, good. So it's a beautiful bot. Lots of improvements. Looks like they're ready to go. Thank you so much, Scott. Appreciate your feedback. Appreciate everybody. See you guys soon. Bye-bye.
Bye-bye.